Gotcha.
She was asking how to do it. I said, I don't know, I just see that it's on like this pop. Like I know.
All right, so again, let's pull those page 108 and then get mine out here. I tore mine out because we were using it as notes yesterday. All right. Let me make sure I don't want to move. Yeah, I don't really want to do that. Okay, so we're going to start at the top here. We'll do this one together. Okay, you can see there's quite a lot of reading here. Okay, so we'll work through it together though and see what we can do. Okay, so our goal is to take this kind of story here and represent it in this graph. So we'll take some time here. Let's read our labels. These are super important, right? So the x-axis, or t in this case, I guess, is for time in minutes. And then the y-axis, or really the q-axis, I guess, maybe q for quantity, are quarts. It's water in quarts. Okay? So we're being told a bathtub is being filled with water. All right. So if a bathtub is being filled with water, where do you think we're probably going to start? At 0, right? At time 0, we should probably put 0 gallons. Okay. Sometimes we might start at, already there being water in the bathtub. In this case, though, the tub is not going to have any water in it, so 0, 0. Okay, now, after 10 minutes, there are 75 quarts of water in the tub. So that we can represent on our graph by a what? After 10 minutes, there are 75 quarts of water in the tub. How can we represent that on our graph? With a what? How can I show that on my graph? What can I draw? Yeah, Ben?
Point.
Here's a point. With the coordinates, 10 minutes, 75 quarts. So there's 10 minutes. I'm going to go up, 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 up. There's 60. There's, what would this tick mark be? It's between 60 and 90. Halfway between 60 and 90. What's halfway between 60 and 90? Ah, 75. So we can put the point right there. Isn't that nice? Sky, how'd you figure that out? Did you just kind of just figure it out, or did you do something, some math?
You get 90 over 60 would be 30, and then divide that by 2.
Okay, perfect.
15 to 60.
Yep. Okay, so Sky found the difference between these two. The total difference was 30. Dividing that by 2 is 15. So that means this number is going to be 15 away from 60 or 15 below 90, which is 75. So we have a point right there. Okay? All right, so we have that point. Let's continue. Then someone accidentally pulls the drain plug while the water is still running. Okay, so what's going to happen? Well, I don't know. That's a good question. They were probably like, hey, I'm going to help out these math kids. I'm going to pull this thing here to make something interesting happen. Anyway, while the water's still running. And the tub begins to empty. The tub loses 15 quarts in 5 minutes. Okay, so it's losing 15 quarts. Where will our new amount be? Remember, we were at 75 quarts. If we lose 15, where will we now be? 60, that's right. We just subtract, right? Subtract that, 15, so we get to 60. And that's after 5 minutes. Well, here's 10 minutes. So then what will this one be? If that's 10 and that's 20, what's this one going to be? 15. Isn't that 5 minutes later? So 5 minutes later, we're going to be at 60. We'll put a point there. Okay? And then someone plugs the drain and the tub fills for 6 more minutes, gaining... Now that's really frustrating. They did 6 more minutes there.
It really is.
How annoying. All right. Anyway, gaining another 45 quarts of water. So from here, if we were going to gain another 45 quarts, what will we be at? Where will we be? We're at 60, and we're going to gain 45, so that means we're going to do what? 60 plus 45, which is 105. Okay? Now, if you go up here, 90 and 120, that's a difference of 30. We'll use Sky's trick again. 90 and 120, that is a difference of 30. Divide that by 2, it's 15. 90 plus 15, there's the 105 right there. So 6 more minutes later, which is really frustrating, 5 minutes will bring us to 20, so we'll just go a little bit further to the right. We'll go up to that 105. Ooh. So something like this. Okay? After a 15-minute bath, the person gets out. So a 15-minute bath. Yeah. Or really short, depending. Some people like to stay in there for a while, I think. Okay? What's that?
We want to stay for 4 hours.
Yeah. Alex is one of those people.
No.
He lights some candles, reads a nice book. Just kidding. Alex doesn't do that. Alex does ice baths after his football game, so that way he doesn't feel so, sore or whatever.
Actually, they work.
Yeah, I hear they do. I'm a little afraid to try it because it's so cold, but I hear they do work. Yeah. All right, anyway, though, if someone's in the bath, okay, and there's no water coming in or out, what's going to happen to the level of the water?
It'll stay the same.
Stays the same, right? Or the amount of water, I should say. I want to be careful about saying the level will stay the same, but the amount of water will stay the same, right? Unless they spill some out, but that doesn't say that's happening. So 15 more minutes. All right, so each of these tick marks is 5, so we'll go 5, 10, 15. We're going to be, remember, just a little bit more than 35. We're at 36. So it stayed the same. Okay. The person gets out and pulls the drain plug. It takes 11 minutes for the tub to drain. That is, again, a frustrating number. But, okay, so 11 minutes. So let's see, if I go 5, that takes me out to 41. And then 10, that takes me out to 46. But I go one more, 47. And we're draining the tub after 11 minutes. So how much water will be in there after 11 minutes? If we're draining, it's 0. Yeah, it'll be 0. So right down there. Okay? So we have all these points. Now what should we do? Trace them. Connect the dots, right? So water's filling in the tank, or the tank in the tub. We lose some water because that person decides to pull the drain accidentally. Okay? But then we start to fill it up again. Okay? Then the person's bathing, so the water doesn't change, right, for 15 minutes. And then they pull that drain and all the water goes down the drain. Okay.
What if the drain gets clogged?
Ew.
Well, that's a story that we don't have to worry about
That
for
would be
here.
an issue for
Okay.
the plumber.
Right.
Feature.
Yep. Or at least you grab the plunger and you push the clog out. Okay. So we're not going to worry about answering these questions right now. We're going to talk about what kind of graph this is. Okay. Hint: it is continuous. Okay, and we'll worry about domain and range also tomorrow. We're not going to worry about those for right now. All I'm really interested in is getting the picture right, okay, for right now. So what I have for you guys then, number 5, I'd like you to read that one and then graph it as best you can over here, okay? So I'll read through it here for you, and then I want you guys to graph it over here. At the start of a snowstorm, it snowed 2 inches an hour for 2 hours, okay? So that one's a little bit tricky there. It snowed 2 inches per hour for 2 hours. Then it slowed to 1 inch an hour for an additional hour before stopping altogether. 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. Okay? This is going to be a little bit trickier here, but I'm going to let you guys try and figure this one out. Okay? So you guys think about it here and graph it as best you can. If you're unsure, I'd recommend you use pencil, okay? So that way we can fix it if we need to. But go ahead, read through that, and just graph the situation over here. Okay? You have time in hours on the x-axis. You have snow in inches, the quantity in inches on the y-axis there. Okay? So see what you can come up with there. This one's going to be a little bit trickier. All right, but give it a try. See what you can come up with. Okay? And if you're stuck, I'll come around and help too. Okay? If you feel like you're stuck, I'll come around and help some. But do your best, and again, please do it in pencil, just in case you think you might make a mistake. Okay? See what you come up with here. So I would say I would probably start at 0, 0. Just at time 0, there's no snow, and then the snow starts to fall. So then after 2 hours, how much snow should you have? So be careful. It's snowing 2 inches per hour for 2 hours. So it's snowing 2 inches per hour. After 2 hours, how much snow will be on the ground? So again, let me say it one more time. It's snowing 2 inches every hour. If it snowed for 2 hours, then how much total snow would have fallen? 4 is what you should get. So after 2 hours, you should get 4. At 2 hours. Where's 2 hours? There you go. It should be 4 inches. There you go. Okay? A little bit tricky there.
I've run out of hours.
So then slow to 1 inch an hour for an additional hour. So you're on the right track here, but it's still snowing. So what's happening to the amount of snow on the ground? You should be right. So instead of going down 1, you should be going up 1, right? So then the first one says it snowed 2 inches an hour for 2 hours. Okay? So after 2 hours, how much snow are you going to have? It's 2 inches per hour. So then you see it's 4. So at 2 hours, you should be at 4 inches of snow. That's the biggest you have. Okay? And you can draw the point so that way you can more easily connect the dot that way.
Does that match yours?
Okay? Now the next sentence, the snow slowed down to 1 inch an hour for an additional hour. So how many more inches do we gain from snow after that next hour? 1. So for the next hour, we're now 3 hours. How many inches of snow should we have? 5. So 3, 5. What you should have. Yeah, so connect that 2, 4 to 3, 5. Okay? And then the next one. For stopping. 3 hours after snow stopped. So now 3 hours later is where what time? 6. And snow has it increased or decreased? Same thing, so flat for those 3 hours, right? And then finally, it began to melt at 1/2 an inch an hour for 2 hours. So we're losing snow now. 1/2 inch per hour for 2 hours. So how many total inches will we lose? 1 inch over 2 hours. So 2 hours later, you have to go out to 6, and then you have to go out to 8 hours. And you'll be down 1 inch. So at 4, right? So 2 hours later, at 8, right? Which point? All right. Good job, guys. All right. Here we go. Let's go to Catherine. Catherine, where, at time 0, Catherine, how much snow was already on the ground when we started this thing? None. Exactly right. 0, 0. We got a point right there. Boom. Okay. Then at the start of the snowstorm, it snowed 2 inches an hour. That was a rate for 2 hours. Okay. So let's go to Hannah. So Hannah, how much snow are we going to have at what time? So if it snowed 2 inches an hour for 2 hours, what's the point I could put there? 4 inches at what time? Yeah, so 2 hours later, it snowed 2 inches per hour. So at 1 hour, we would have 2. At 2 hours, we would have 4. Yes, question? You're okay with this, Dylan? Actually, can you wait till we finish this and then go? So as soon as we're done with this one, you can go. But I just want to be here. I want you to be here just so you can make sure we're okay there. So at 2, 4, boom, we're connecting there. Okay? Great job. The next sentence, or next part, I should say, says, then slowed to 1 inch an hour for an additional hour before stopping. So let's go to Reagan. So Reagan, if it slowed now to 1 inch an hour for an additional hour, okay, how much more snow do we gain after that next hour?
Yeah, see, I did that wrong.
Okay, that's okay. So how much do we gain?
Alright, so it's at 4, right?
It's at 4.
So would it go to 5?
It would go to 5 in 1 hour. So 1 hour later, we're at 3, we're now at 5.
Yeah.
Okay, so it's slowed down. And so how do we see that slowing down here? The idea is that this slope is not as steep as this slope, right? This slope is steeper, so it's a faster increase, 2 inches per hour. This is a slower increase, 1 inch per hour. Okay? All right, let's keep going here. All right, Tyler, the next part says, Tyler L. Before stopping, 3 hours after the snow stopped. So at this point, we've now stopped. How can we show that the snow stopped falling here, Tyler? What's going to happen to our graph? Are we going to increase, decrease? What? Sorry, Tyler L. You, Tyler. So.
It would stay the same.
Yes, very good. We're not adding snow. We're not losing snow. And we're going to stay the same for 3 hours. So that's going to go to 4, 5, 6. Just like that. Flat. Okay, sorry. That looks like it went down some. It should just stay flat like Tyler said. Okay, perfect. However, now, after this, it says 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. So, Daniel, we're melting. What's going to happen to our amount of snow here?
It's going to go down 1/2 inch for 2 hours.
So where are we going to end up? So we're at 6. We're going to go to 7 and then 8. And how much are we going to lose? If we're melting 1/2 inch for an hour and we're doing it for 2 hours, how many total inches of snow are we going to lose? 1 inch. So we're going to go from 5 down to 4, and that'll be at 8. Okay? And so there's our graph right there. Boom. Okay, just like that.
We did it.
We did it! Great success. Okay, so that's the answer right there. Okay? All right, so that's the only one we're going to do. We're not going to do number 6 because number 6 has to do, well, you'll see tomorrow what that one's. It's a little bit different. I'm going to hold off on that one for right now. But Miss Mulcahy's going to come around and give you guys.
A Tootsie Roll Pop.
No.
Sorry, guys. I tried.
No candy yet.
How much is it?
Maybe one day. Okay, there you go. Okay, and so Dylan, if you want to go now. Thank you for waiting, Dylan.
Wait, so are we doing our books anymore?
So again, you are done with the books for right now. You can put them away.
Yeah, are we gonna do homework or not?
No, the homework will be a separate sheet of paper. So, good question.